Okay, we're still working with the quotient rule. We're still working on simplifying. So again, 3 rules we got to be aware of. So when I look at this, check the indexes, make sure they match. I also look for where the division is to make sure I have all the information. This is a division through them, or between them. It's not a division within, and you have to recognize that. But recognize this 2 is outside the radical. So this 2 is outside the radical for both of them. So that 2 cannot divide into that 48. Unless I can take something out of here and it comes outside, I won't be able to take care of that. So if you go through, remember there's always a 1 times everything. The reason I want to mention that is because this is really a 1/2. I could do 1/2 times that entire expression just to make sure it's out of the way. So when I look at this, I know rule 1 is prevalent. It's there because I have a 4th root, but I have powers that are greater. There's information I can take out. So hopefully you're looking at this and saying, well, I have rule 1 that I have to take care of at some point. Now you can take out information here, you can take out information here. Again, I recommend putting it together. Hopefully you're also saying rule 3. Rule 3, we got a radical in the denominator, and I can't have it. Now we've had radicals in the denominator before, and it was a perfect square, perfect cube. We could evaluate. Well, these are not perfect to the 4th powers. So what I would recommend is I'd put it together. Now I'm going to utilize the fact that I made that a 1/2. So this is going to become, 1/2 times, this is going to become 1 radical. So 48 x to the 9th y to the 13th over 3x y to the 5th. It really just becomes an 090 problem. If you forget that radical is there, it's just the quotient rule. Utilization of the quotient rule. So the stuff we did with the rules of exponents. But don't lose that radical. Putting this together does not lose that radical, but also don't lose the index. So I have 1/2. If I go through and simplify, 1/2, 3 goes into 48 16 times. X to the 9th over x to the 1st. 9 minus 1, I have x to the 8th. Be mindful of negative exponents that appear. If it appears and it's in the numerator, move it to the denominator. If it's in the denominator, you can move it to the numerator. 13 minus 5 is 8. Okay, and it's still the 4th root. So I have 1/2 times the 4th root of 16, x to the y, y to the 8th. If I could take information out from the denominator, remember when I take that information out, it's still in the denominator. Be mindful of that. Okay? So we want to start dividing by information. Well, I already know that 16 is 2 to the 4th. So I'm going to take that 2 out. Well, hopefully you do this enough and you start doing that division. 8 divides by into 4. 8 divided by 4 is 2, so I have an x squared. I have a y squared because it's the same division. Remember, 8 divided by 4 goes in evenly. I wouldn't have anything inside the radicals. When these are divisible by this number, whatever it might be, if they're divisible, you can take everything out. So that's still 1/2 times that. But 1/2 times 2 is just going to be 1. That's going to be x squared, y squared. Sometimes they come out relatively nice. Just be mindful. You're going to want to look to find the rules of exponent sheet. It isn't in the take-home folder. I will also put it in the this week's folder for you to find. You can utilize that on, you won't need it on necessarily test 3, but on everything after that you'll be able to utilize it. It's got all the rules, it's got the rules of exponents, it's got some simplifying forms for the radicals, and it also has the 3 rules for simplifying radicals that you can utilize. Don't think I have a copy here with me to quickly grab. What we're going to do next in the next clips, we're going to go through and learn how to approach it. Now this is a way, and to me it's the quicker way, but how can we approach it when we don't recognize this and we have something like this where it's not a perfect nth power? How can we take care of those? So we'll do that in the next clip.